So now we are live. So today is something where we are going to begin our linked list part. Yesterday's question was quite simple. Now let's jump into something more unique. I feel linked list is one of the topic which is very easy in DSA. So let's move with positive attitude to this question. And the question is quite easy with a tag of easy. What is the question? Finding uh, let me write by side. So the question is finding middle element in English. Quite simple. The brute force. So let's first understand the question. I will be using Geeks for Geeks today. We are given a single linked list of n nodes. The task is to find the middle of the linked list. For example, if the linked list is 1, 2, 3, 4, 5, the middle of of link the middle node of list is 3. If there are two middle nodes, in case n is even, the print the second middle element. For example, 1, 2, 3, 4, 5, 6, then the middle node of list is 4. So quite simple, just we have to return the middle part of linked list. Traversing and working with linked list is quite a hassle, but once we are familiar with it, it's easy to conquer. So as we know, we can't move backwards, and it is a singly linked list. So we have to start traversal from the head. We can't directly jump from end or something like that. We can't use two pointer approach or anything like that. So in linked list there are few topics which must be remembered. Uh, Among those, we will be discussing one of those today. So how middle would be the second element, which is 3. So how is this happening? The brute force approach might look like, let me change to what's this, my pen and paper. So the brute force approach is where we will first traverse once the whole linked list to traverse whole linked list to get length. Second, we will again traverse from head to n by 2 element. Quite simple brute force it was. Optimal, we will be using fast and slow pointer. Fast and slow pointer is a very important point in what we say linked list. So before moving on, the brute force approach will result in n plus n by 2 time complexity, and space complexity would be O of 1, I feel. Yes, over one would be right because we are not storing any data structure or something like that. So in optimal, how does fast and slow work? One, two, three, and four. So for slow and fast pointing on same element. Now how is that working is slow will do slow dot next, fast will do fast dot next dot next. So it will be here. Then again fast will come over here and slow. So what is the funda is we will loop until fast is not equal to null or fast dot next is not equal to null. So quite simple. Let's move on to the implementation side, or let's go because I don't feel there is something more to be shown. So how we will start is by initializing the fast equals to head, slow equals to head, while fast dot or might not work over here because in any of the both cases the loop should end, not wait for both conditions to be satisfied. Fast not equals. Hmm. So what we will be doing is slow is equals to slow dot next, fast is equals to fast dot next, return slow, compile and run. So simple. Oh, they don't. Acha, they want the data now. Slow dot data. My bad, my bad. Completed. Might have taken barely 5 minutes. Phew. At 63. So, okay, my bad, my bad. This condition comes after this because if first is null, this will never be positive. This will never come. But if we do this, there is a possibility that next is null. So we can't iterate it. Quite simple. Let's go and move on to the next question in the next stream. So the next stream I am going to continue now only. Before moving on, let's revise our previous set matrix 0. What was the example? Okay, so here what can we do is in a hash in a row and column array we can store the position and then iterate the row and column array to set the rows and columns. Let's see the brute force. What is brute force? Iterate the whole array. Yes, right. Set the position. Update the rows and columns. I thought the same. I was checking my notebook for the previous dry run. So approach. First we will use two nested loops to traverse the cell. Contains 0, we will mark the cell in the row. If any cell contains value 0, we will mark all cells in the row of I and j except those which contain 0. As we perform the step 2, for every cell containing 0, finally we will mark the cell. Eh? Okay. First we use two nested loops to traverse all the cells of the matrix. Let's do dark mode. My eyes were burning. If all the cells contain value 0, we if any cell contains, we will mark the cell in the row I and column I with -1, except those which contains 0. Hmm, we will perform step 2 for every cell containing 0. Finally, we will mark all the cells containing -1 with 0. This okay. So see over here it is 0, so it will mark all the with 0. Then it will mark with -1. Let's check the code. So the brute force mark column, mark and row. If not equals to 0, mark set it to -1. Quite simple. So if it encounters 0, it will mark the whole row with -1. And after marking all the rows and columns with -1 where 0 occurs, it will set the -1 to 0. Okay, so better approach. Let's jump directly into code. The theory part makes me lose distract. Yes, I was saying this one. Uh, Traverse all elements. If 0, mark the row of I with 1 and row of j with 1. Okay, and if row of I equals to 1, we will set it to 0. Yes. So the optimal is column 0. Okay. Step 1, traverse the matrix and mark first row and column accordingly. If map.get I, j equals to 0. Okay, so the map dot so the column 0th column we will be setting to 0. Mark the jth column if j not equal to 0. Matrix dot get row 0 set j to 0. Okay, else column 0 equals to 0. Mark with 0 from 1 comma 1 to n minus 1. If matrix dot get I comma j not equals to 0. If matrix dot is equals to 0 or this is equals to 0, we have to set it to 0. Okay, so they are using the first row and column to store which rows and columns should be marked to 0. Finally, mark all the first columns and then first rows. If column 0 equals to 0. For why is why are they doing this? So for every row set okay. Here column 0 is kept to ensure that if column 0 is to be concerned, we are using a variable, because if column 0 is marked as 0, everything what we say, we will not be able to get all the rows which are going to be marked as 0. Right. So what if first row is marked as 0? It's okay, we are just concerned about which rows. No, how then columns are stored? I comma row mark dot get 0. Okay, so if column 0 contains 0, so if column 0 contains 0, we are using column 0 this variable, or else the row 0 contains all the columns which are marked 0. Okay, fair enough. Quite simple. Let me go back to pen and paper and write down the optimal approach for set matrix 0. I don't see any space to do so. In optimal, we will use column 0 variable to mark if column 0 needs to be made 0. And so the first column of every row we will keep count. So for this example, we will update it over here. So this row needs to be 0. And similarly for the col yes, these are columns, yes. Similarly for columns, here we will mark it as 0. So we know this row and this row needs to be zeroed. So simple. I mean, I have not implemented this one, but I'm confident I can do on my own. Pascal's triangle is also quite simple. So how is this going to begin is, if length is less than 1, am I right? If length 0, 1, yes, if length is less than 1, add until length becomes 0, or else take the sum of previous array and continue doing. Am I right? I mean, I'm confident in it. So what I have written the logic here is, start by adding 1. If previous length is greater than 1, 0, 1, sum in current. Length equals to count of elements. Okay. Last element always 1. Okay. Yes, see, I was telling this. If length is means I is less than 2, less than or equal to 2. So what we are doing is I is 1 and 2. Then we have to not take sum of previous and just set I to 1. Let's check what driver telling. So what is the variation 1? No, not this variation. Let's do variation 2. Mm, not this one also. Let me show you all my logic. Control new SDE drivers SDE sheet. So now let me add my Chrome's browser. Pascal. Oh, I am starting this. How I approach this question is quite different. I am also using a nested loop where I is first index to 1, and if j equals to 0, we will just add this, and in this condition, uh, what we say, the last element, for last element this is the case, but now I am thinking that I could have just passed this over here, ARR of I minus 1 equals to 1, but it's okay, not such bad thing. So we will just access the previous array and take the sum. Quite simple question. Hmm, let's revise another next permutation. Find the lexical. Oh, this is quite interesting. I would like you all to see the learning on the paper, pen and paper. next permutation.
next
So
permutation.
there is a
So
fixed logic over
there is
here.
a fixed logic over
So
here.
how does this
So
begin is
how does
from
this
the
begin
right
is
part
from the right
find the
part
largest
find the
non-increasing
largest non-increasing
suffix.
suffix.
So
So
here the violation
here
is
the
there.
violation is there.
So we will stop
So
over
we will
here.
stop over
Then
here.
we will
Then
try
we
to
will
find
try to find
the
the
largest value
largest
from the
value
right,
from the right,
larger value
larger
from the
value
right
from the right
of the
of
pivot.
the pivot.
So
So
we
we
identify the
identify the
pivot,
pivot,
then we
then we
find the
find the
rightmost
rightmost
successor
successor
and
and
swap.
swap.
So
So
3
3
was the
was the
successor
successor
and we
and we
swapped.
swapped.
Then
Then
what we
what we
did
did
is
is
reverse.
reverse.
So
So
this
this
part
part
gets
gets
reversed.
reversed.
This is
This is
quite
quite
something
something
which
which
we
we
must
must
have in
have in
our
our
mind.
mind.
So
So
okay, next permutation is also quite not a big hassle. Let's move on to Kadane algorithm. Okay, okay, I know this one. So how this works was find the maximum sub array with zero sum. So as long as I remember, we will keep on continuing the count. If sum becomes less than zero, we will update the sum again to zero. And for every iteration, we'll check the and keep store of max sum. So how the brute force is being taken into consideration. Let's see. Oh my god, n cube. Better would be the n square solution. Yes. Here for every j element, they will check the subarray and try to find the maximum subarray. So let's go up. Optimal question. Mm, For int I, they will do some calculate sum. See if the sum is less than zero. What we are going to do is reinitialize sum to zero. Okay, quite simple. The follow-up question would be printing the subarray. So for printing there we will require or not printing we will need length or what. Let's see what is the question. Find more find more than one subarray with maximum sum. We need to print any of them. Is there any example or something? There might be more than one subarray with maximum sum. Okay. We can't sort over here because we need subarray. We must always keep mind of that thing. So in short what they want is what is the question? The subarray is okay, the maximum sub 6. See here they are printing it. Okay. So they are just wanting the maximum subarray to be printed or they need a start and end pointer. So how this works is if sum becomes 0, they will get index I. So what does this mean? A new sub array is going to be started and the starting index of that sub array we are storing it over here. Then we will do sum. If sum reduces. This is the common part. Uh, Answer start if the sum is greater than uh, the previous total sum. We will update it, and the longest subarray indexes are stored like this. So the start in the logic of start I have explained previously, and end is where the sum is currently at, and the sum is currently at as of now being the largest sum. So from now till the start position, this is the largest sum, something like that. Quite easy, just simple addition was of this condition. Okay, so should I do both today? I will do this in the next stream. I'm going to start the stream now only. No, I'm going to do this revision now only. Because in the next stream we will revise the next questions. So short. Oh, this question I remember it very clearly. This was the question what it was pain in my eyes. So here they are using the flag method. Flag. So what is it called? Dutch national flag algorithm. So how does this work is since we are having three elements only, elements with these three values only. So we are using three pointers for each. The greater values pointer will end at the end of the array. So the 0 and 1 will point at the start. Let me check if I have the dry run for it. What's the question? Yes, short. Yes, I have it. So let's go over there. So I'm directly jumping into optimal because the this is the one I had just referred because I was not able to solve it, so I directly jumped into optimal. But let's first see the brute force only. So how does the brute force work? What's the intuition? Sorting, even if it is not expected solution here, but it is considered as one of the approaches. Okay, directly sorting it. It's not logical. Means it's not what they ask for. So the second approach is to keep count. Let's consider count intuition. Since in this case there are three distinct values in an array, it is easy to contain the count of all, like 0, 1, 2, and can be followed by overwriting the array based on the free. Okay, this is quite unique. Yes, we have used three variables, going to store the frequency, then updating uh, this by until the count becomes 0. So while I is less than count 0 plus count 1, then I is equals to count 0 and 1 till the end of the array. Optimal, let's go. So how the optimal will begin is, have they got, yes. So for 0, 1 they are pointing at the 0 position, and high which is for 2 they are pointing at the last position. Hmm, the explanation is like quite mid. let me show you how to how I have done it. If the value of I is equal to 0, we will swap it with 0 and 1. Then we will increment 0 and 1 pointer by 1. So why we are swapping it? Because let's first see the dry run. So first the value is 2. So we will replace it over there and swap it. After which we incremented the high value, decremented it. In the second iteration, we are at I again. So I is again at 0 while 1 is, since 0 is at its the correct position, we will do 0 plus plus, and uh, we will do 1 plus plus also, because both values will move ahead. So till now it's all going correctly. Now we are at this post position. It is 0, so we will again do 0 plus plus and 1 plus plus. So 0 means low and mid means 1. So we will increment low and mid values. Now we came across 2. We will swap it with the high position and do high minus minus. Now we are again at the position where 2 was. Now it contains 1. So what we will do is do one high plus mid plus plus. Low is pointing at the same position. Now if over here it was 0, so what would happen is it would swap with the low plus uh, low value I. So what is happening over here is it will swap with 0 and 1, because uh, if if it were 0 over here, but low pointer is pointing at the lower value, which is 1. So it's the best case would be to swap it and then increment low by 1 and high also by 1. But after which we see is that low and high are greater than each other, so the loop will end. Okay, quite simple. Stock buy and sell. The best time to buy. You have, mm, for now I am thinking, what if we have sorted it? No, it can't happen, because if we sort, the lower value, if it were on the right, would come on the left part. So that might lead to misconceptions. So let's check what the brute force approach is. I mean, I'm not interested in it, but first of all, we must explain the interviewer the brute force, then try to come up with optimal. So for every I, we will check J, then again for increment I, then check for J again, and do the max value counting uh, appropriately. So what the optimal approach is going to be is, we will have to take 3 pointers, one I and then low and high. So we will increment I and if the value is greater than, so min and max both are pointing at 0. In minimum price, we will find the minimum price as well as try to do the max profit till now. So how it is going, we will increment and try to find minimum price, and for every I we will check the profit it results in. If the profit is greater, then we will update it. So the worst case would be minimum and max profit will result, means I is on minimum profit, so 0, it will result in 0. So the worst case would be 0. But if the I is pointing at a higher value, something like if I is over here and it the at 6, and it has occurred the lowest profit it has stored, which is of 1. So if we check the profit over here, it would be 6 minus 1, which would result in max profit of 5, which would be the highest. ARR of I equals to 4. 1, 2, 3. ARR of I equals to, okay. So 4 minus 3. So max profit remains the same even if I minus the lowest value gives the lesser value. Okay, so now I am going to start the next stream to solve which question? Um, Merge sorted linked list question. Okay, let's meet. I will meet you in 2 minutes.